Assalamualaikum warahmatullahi wabarakatuh. We from Group 13 would like to show our report project in this video today about the traffic signboard. Our lecturer T.S. Muhammad Syamil bin Zakaria. Our team member from left are Muhammad Haziq bin Abdul Ghani, Syahrul Naim bin Rizal, and lastly Muhammad Arif bin Naziri. The software that we use for this project is SolidWorks. Other examples for CAM software include WorkNC, Cement, and the SurfCam that we use for this project. After done with CAD and CAM, we will use the CNC milling machine. This design was chosen with the intention of making the notice board more aesthetically pleasant and intelligible to people traveling along the traffic road. Road users are less interested in seeing such items because each signboard at traffic is so boring and plain, which means many accidents can occur because of their careless in noticing the signboard that occur in their way. As you may know, each signboard was made from aluminum or stainless steel and then was painted and drawn at the flat surface of the steel. From the figure below, number 1 are contour feature, number 2 are fillet feature, and number 3 are pocket feature. This is an improvement we made in this design. From the orthographic view, or we call as engineering drawing, are produced by projecting an object perceptive onto a plane that is typically positioned parallel to one of the object plane. As we can see, the contour feature is 3 mm in size and the pocket or deep hole is 2 mm from the signboard face. Also, don't forget that fillet feature has a radius of 1 mm at the pocket feature. From the top view, we can see the height only left are 50 mm from 25 mm.
The term CNC milling machines refers to the equipment used in CNC milling processes. The tools steadily remove extra material to produce a correct form and size as they rotate and travel across the workpiece surface. Three factors work together to produce successful, high-quality milling, including a cutter with many teeth and the right amount of sharpness for the material, a tool spinning at a high enough speed to process the material correctly, and an appropriate feed rate for moving the selected material through the processes. The computerized system eliminates the possibility of error between design and manufacturing by reading design information directly from an engineer's drawing or models. Machining operation may be carried out by CNC machines because to the variety of CNC machining equipment available. These carried CNC tools' unique characteristics enable them to be used for a variety of applications while requiring less manual input from machining operators. Enemy tools usually have a flat bottom but not always. Round and radius cutters are also available. So in this project, we are only use one tool which is include the pocket process, fillet process, and contour process. The criteria of the tool will select the tool is the tool can work at any type of shape and corner. So the perfect tool that have been chosen to use in the process is 5 mm for flute, which is HSS and mill. The length of the flute on this tool that has been selected is 13 mm. So the total length of this tool is 47 mm. The shank diameter and the diameter of flute is same, such as 5 mm of diameter.
There are 5 primary operations to make the project. First one is two-axis pocket process. As you can see, the top picture, the surface excluding the triangle shape and the two-axis pocket must be made to surround it in the first step. A pocket is built through the roughing and finishing procedure. For the roughing process, the z-axis will be sliced to a depth of 10 mm. It will move through about a 2 mm wide chasm in the z-axis. The finishing procedure final spacing is 0.2 mm. And the second picture is creating the two-axis pocket inside the triangle form while putting the special attention on the three-junction logo, which has depth in 2 mm. On the left side picture is process to create a contour by creating using three-axis cut. For running the three-axis operation, the step size and also surface tolerance are so important in this procedure. The value of step size and surface tolerance are shown on above picture. These values are the perfect value that need to put inside the cut control system. On the right picture is a finishing of simulation process. The parameter that we set up incompatible with the type material we utilize. The parameters finish speed and feed rate are 5411 and 3246.761. The value of feed chip load, surface feed and plunging rate are shown in above picture. Okay, thank you.
Before beginning the machining and manufacturing processes, the machine must be set up first. Then, the software must be sent from a pendrive via USB to the CNC machine. Third, adjust the tool to the one we will be using and set the offset of the tool for CNC cutting. The workpiece must be put at the fixture in order to establish the coordinate data for X, Y, and Z. Finally, after finishing all operation, we must start the CNC machining process. Here is a video showing our procedure as the machine is being operated.
For our product analysis, there are some differences for our original drawing project. For example, from the part dimension, there are some specific parts that have not been cut. So we use a knife to cut that area that has not been cut. For product improvement, we advise using the appropriate tool for the certification process.